into the tri-state area, hitting us roughly today. Temperatures for today will be high in the upper 40s with a chance of rain 30%. However, it'll be dropping down tonight to the low 30s, so bundle up, make sure you have your umbrella for today.
Okay. Thank you, Eva, with the weather. Our new segment today is blood pressure control. It is known that 1 in 3 Americans suffer from high blood pressure each year. With that being said, we're going to discuss how blood pressure is controlled by hormones and the kidneys. And later on in this segment, Eva will be interviewing Dr. E, who will discuss the long-term controls of blood pressure. To begin, there are 3 main short-term controls of blood pressure. The first one is adrenal medullary hormones, which are located in the inner part of the adrenal gland. It helps a person cope with the physical and emotional stress. There are 2 different kinds of these. Epinephrine, also known as adrenaline, increases heart rate and force of contraction, facilitates blood flow to the brain, and causes relaxation of smooth muscle, which increases blood pressure. The other one is norepinephrine, also known as noradrenaline, which has little effect on smooth muscle, metabolic processes, and cardiac output, but causes strong vasoconstriction, which increases blood pressure. Following that, the second hormonal control of blood pressure is atrial natriuretic peptide, also known as ANP. It's a hormone secreted by the atria of the heart in response to an increased atrial stretch, lowering blood pressure. It stops the aldosterone secretion and reduces the release of renin by the kidneys. This increases secretion of sodium and water from the body. It also increases vasodilation, which is the increased diameter of blood vessels. Less water and sodium decreases blood volume, which works together with vasodilation to decrease blood pressure. And our final hormone control we'll look at is antidiuretic hormone, ADH, also known as vasopressin. Antidiuretic hormone works with the kidney to conserve water. When blood pressure fails, ADH is released by receptors in the hypothalamus, which helps increase blood pressure through vasoconstriction. Alright. Now we will move on to discuss the long-term hormone control of blood pressure that has recently been discovered. We're joined in the studio today by Dr. E, who is credited with the discovery of the hormonal regulation of blood pressure.
Thank you so much for coming in, Dr. E.
It's my pleasure.
Okay. As you established before, blood pressure can be regulated on a short-term basis by hormones, correct?
Yes.
But what about long-term regulation? What can you tell us about this?
I'm glad you asked that, Eva. Long-term regulation is very important in controlling a person's blood volume. Hormones known as renin and angiotensin work alongside the kidney to stabilize a person's blood volume. Now, there are 2 ways this can be accomplished, either direct or indirect renal mechanism.
So what's the difference between the 2?
Let's start off with direct renal mechanism. Simply put, direct renal mechanism works without hormones to alter blood volume.
And what about the other one, the indirect renal mechanism?
This is where it gets somewhat complicated. Indirect renal mechanism, also referred to as renin-angiotensin-aldosterone mechanism, uses the 3 hormones mentioned in its name. The process begins when arterial blood pressure drops. Cells in the kidney then release renin enzymes. In turn, renin stimulates the production of angiotensin. Once angiotensin reaches the lungs, it is converted to angiotensin II through angiotensin-converting enzymes known as ACE. Angiotensin II is the key hormonal player here. Angiotensin II proceeds to work in 4 different ways to return blood pressure back to normal. First off, angiotensin II increases the production of aldosterone, a hormone that induces the reabsorption of sodium in the kidneys. Angiotensin II also increases the release of ADH, which we talked about before, the hormone that increases water reabsorption in the kidneys. It acts as a vasoconstrictor, which increases blood pressure and causes thirst, encouraging water consumption. Fortunately, renal failure leads to hypertension, which is increased blood pressure.
Wow, that's quite a mouthful. Is there any simpler way you can explain this to our public audience?
Yes, I have brought a video clip with me that puts what I just said into more simpler terms. The renin-angiotensin-aldosterone system is a classic endocrine system that helps to regulate the long-term blood pressure and extracellular volume in the body. The system begins with the release of angiotensinogen into circulation by the liver. This may be in response to low blood pressure and changes in sodium concentrations. Renin is secreted by the kidney, which cleaves angiotensinogen to form an inactive form of angiotensin I. Then, further transformation of angiotensin I is carried out by angiotensin-converting enzyme, or ACE. ACE is predominantly found in the pulmonary circulation. However, it is also produced in the endothelium of capillaries and other body tissues of the brain, heart, and adrenal gland. The angiotensin-converting enzyme converts the inactive form of angiotensin I into the vasoactive peptide angiotensin II. Angiotensin II acts in 4 ways, 2 of which are shown here in this animation. It causes vasoconstriction of the blood vessels, and it also causes the adrenal glands to release the hormone aldosterone, resulting in sodium retention. The third way is angiotensin II triggers the sensation of thirst by activating the hypothalamic thirst center, encouraging water consumption. And finally, it prods the pituitary to release ADH, which promotes more water reabsorption in the kidneys. These 4 things work together to increase blood pressure. In the final stages of the renin-angiotensin-aldosterone mechanism, the kidney reduces the production of renin, ending the mechanism.
Thank you so much for joining us today, Dr. E.
Thank you. It was my pleasure.
Now back to Kimberly with the closing remarks.
Thank you for joining us on our segment about hormonal control of blood pressure. Be sure to tune back in for the 5 o'clock news.